All right, in this last video on dealing with graphing in degrees, we're going to have all four of our transformations happening. We're going to have an amplitude change, which we'd see with the number in the front, a period change, which is when there's a number multiplied by x inside the parentheses, a phase shift is when there's something added or subtracted inside, and a vertical shift is the number on the end, right? So it's helpful to go through and identify these things first, especially when there is both a period change and a phase shift, because it's not just as obvious as you might think, right? Amplitude's gonna be a 2, that's easy. Vertical shift is down 1, that's easy. Let's stick with that part first, okay? Now, when we have things in the parenthesis, if there is a number in front of x that's being multiplied and a phase shift, we need to factor this number out in order to accurately figure out the phase shift, how much it's shifting left and right. So we need to factor out whatever this number is. It doesn't matter if it divides evenly with 90 or whatever the other number is, you have to factor out this particular number. So if I factor that out, right, it's basically just reversing the distributive property. If I multiplied this 3 back in, I get what I started with, right? So factoring it back out, we have to have this just say 1x or x plus or minus something in here to accurately figure out the phase shift. So the phase shift is actually plus 30, or to the right 30 degrees. Right, so we have to have this number in the front here be a 1 if there is a phase shift in order to accurately figure out what the phase shift is. Right? Now for the period, this number that was in front and the number that we also had to factor out, we're going to do the inverse of that. So this was saying multiply by 3. So we're going to take the normal period length and divide it by 3. So our normal period, or our period in this particular one, becomes 120 degrees. So that's the length total, but I'm also going to start 30 degrees like further to the right than we normally do. Right? So this is going to involve a few different things happening to the intervals. Instead of just adding 30 to each of them, we also have to kind of shrink it down, right? So how do we tackle that? So to deal with the intervals, we are going to do the inverse. See how this stuff connects, all those inverse things we did? We're going to do the inverse of this right here. And I think factoring it out actually helps you know which parts, first and last. So having these steps, how we found the inverse was we either listed the steps and then did everything backwards and the inverse operation, or we switched to the x and y and then resolved for y. So currently what's happening here, if I were to plug something in for x, currently what I would be doing is I would minus 30 and then I would multiply it by 3, right? If you were to plug in a 1 or a 0 here, whatever, right, or 90, plug in it, you'd minus 30, then times 3. So to find the inverse of that, we're going to do dividing by 3 first, and then plus 30. And this is what we are doing to each of the intervals to figure out the new numbers, right? Now, if you think about it, the first one should be pretty simple to figure out. We're not changing really the distance on this very first one. Normally we start at 0, we should be starting at 30, so that's kind of maybe to check if our stuff's working out. So we're going to take our regular intervals, which I'm going to write them down here just in pencil first, because we start having a lot of things happening. I don't think did I mention this is actually a question from one of the homeworks. This is a question from homework 7-11. This is problem number 1. So if you need help on that. All right, so here's our normal intervals. So what we're going to do with each of these, again, how we figured this out, we're going to take the inverse of this factored out version of our equation. So currently it's minus 30, then times 3, if you were to plug something in this x spot. So the inverse, we're going to do everything backwards and the inverse operation. So instead of times 3 last, we're going to divide by 3 first, and then we'll plus 30. So 0 divided by 3 is 0 still, and then plus 30 makes it 30. All right. 90 degrees divided by 3 is 30, plus 30 makes this 60. All right. 180 divided by 3 is 60. 60 plus 30 is 90. All right. We should have equal intervals happening throughout here. So after you figure out your first couple, you could just, okay, I see it's adding 30 each time, so we could just add 30. They should be equally spaced out intervals. But just to keep checking, 270 divided by 3 is 90, 90 plus 30 is 120. And the last one, 360 divided by 3 is 120 plus 30 is 150. Right? Now this time our ending number is not just our period length, right? Because not only did we change the period, we changed where we started. But the distance between 30 and 150 is 120 degrees. So our period is still the correct period length, which is the 120. And we also started at 30 degrees kind of earlier, I guess, than normal. Right? So those two things kind of happen together when we deal with these new intervals. So we took care of the horizontal part. Now we're going to take care of the vertical part. All right, and this is a sine function. It's getting a little bit messy with my marker here, but it's okay. So sine starts at 0 normally. Up 1, 0, negative 1, 0. Okay. So I dealt with the phase shift and period change. Now I'm going to do the amplitude. So everything times 2. All of my y coordinates times 2. Again, this is going to get a little bit messy here. Times 2. Oh, actually, wait, that stays there. This times 2 is up, stays there. That's at negative 2 and stays there. All right, all the ones that are 0 will just stay there if you're multiplying. All right, so we did that. Final thing is the vertical shift. Everything just moves down 1 unit. So from 0, we're down now to negative 1. From 2, we're down to actually where it started in the first place. Down 1. Down 1. Now this is going to be at negative 3. Let me try to mark that. And then the down 1 is at negative 1. Okay? So my pink is my final version of the actual equation right here. That's the pink version. And again, you can graph this on your calculator. If you change the window settings to go from 30 to 150 for your x's, and then your y can go from negative 3 to 1, and you should see just one exact sine curve in that space. Okay? We're going to look at one where we're doing all 4 changes happening. This is also a question on the homework. This is from homework 7-11. And this is number 4. So we got all 4 things happening here. So again, I think it's best if we identify all the little pieces first and then deal with the graph afterwards once we know what's going on. And vertical shift. All right. Easiest ones first are the amplitude and then the vertical shift, which is typically on the end, but remember it can kind of trick us like it did in that last video where it had a number in the front that was being added. So amplitude's 3, vertical shift is up 1, or you could say plus 1. Right? Now when we have a period change, which we see by this number being multiplied here, and we have a phase shift when there's something that's being added or subtracted, we have to factor out this number no matter what. So 2 times something to make 60, that would be a 30 right there, right? Oh, this happens to be doing the same thing as the last one, but that's okay. So our phase shift is going to be positive 30, or to the right 30 degrees. And to find our period, we're going to do the inverse of what this one is currently doing. It's 2 times x, so the inverse of times 2 would be dividing by 2. So my length is going to be 180 degrees, so it's only half as much, and I'm also starting 30 degrees to the right of normal, right? So to deal with these two, we're going to change the intervals. So I like to look at what's happening here in this factored out version. What's currently happening, if I were to plug in a 0 or a 30 or anything into this x location, what would you do first? Well, you would currently subtract 30, and then you'd multiply it by 2. So we're going to do the inverse of this. So we're going to actually divide by 2 first, and then plus 30 to all of our intervals. Okay? So keeping those in mind, I'm just going to write them down here because honestly, it's easier than trying to do it all in my head and not remember what each of the numbers are. So what we're going to do with each of those is start by dividing it by 2 and then plus 30. All right, just the inverse of what steps we had here. So 0 divided by 2, 0 plus 30, that's 30. Obviously, we should be starting at the phase shift all the time. Those should match up. 90 divided by 2 is 45, and 45 plus 30 is 75. Okay. 180 divided by 2 is 90. 90 plus 30 is 120. I have to double check this next one here. 270 divided by 2 is 135, plus 30 is 165. 360 divided by 2, that's 180, plus 30 is 210. Okay. Now, these all should be going by equal increments here as well. So this looks like a distance of 45, so that should be happening all the way through. All right, they shouldn't be different spaces. The whole point is to keep them equally spaced out. All right, so we took care of those two things with labeling our intervals. Again, the distance between where we started here, where we ended from 30 to 210 is 180 degrees, and that is that period. That length itself is the period. The phase shift kind of means where we start or how we shifted from the normal left and right direction. All right, so this is a cosine curve. So I'm gonna just, again, plot the points here, kind of just to get us a basic line. And then I'm going to do the amplitude, so everything my y direction times 3. Oh boy, it's getting crowded again, but hopefully you can follow it enough. So this times 3 would be at 3. This times 3 is still there. This times 3 is negative 3. Right? This is stretching it taller, just like we did with the stretch factor on parabolas and cubics and all that stuff. All right, so we did that. Last step is the vertical shift up 1. So I need this to kind of be a 4 right here. So we're gonna move all of our points up 1. So now that's at 4, that's at 1, it's at negative 2, 1, and 4. Okay. So my pink is the final version here. So just making sure we keep these steps in order. When we have multiple shifts happening, we need to deal with the phase shift and the period first, and those kind of go together, right? When we have a phase shift and a period is when we did this inverse stuff of what's happening here. We have to factor out whatever number's in the front, and then we'll do the inverse of that to figure out how do I change my intervals. All right? Then we would deal with the amplitude, and then always last is the vertical shift. Okay, so hopefully this helps explain. We have multiple parameters changed, and these are all in degrees, and what we're going to do eventually is do all of these in radians. So hopefully please ask if you have any questions before we start shifting into radians.